I'm Mike, and today, GMOs. Has this human experiment that we've been conducting over the last decade and a half turned out to be beneficial or destructive? Well, we're going to look at 5 reasons why GMOs just aren't worth it when you're actually looking at the real-world effects. A very quick reminder, breeding is different than genetic modification. Through selecting for mutations and breeding, we can turn this black-eyed Susan into this sunflower, but through genetic modification, we can inject this scorpion's DNA into a cabbage. There seems to be a new push to embrace GMOs, and there is marginal evidence that shows that GMOs can be beneficial. But people are acting like all of the risks have been entirely debunked. People like to focus on the theoretical benefits while not actually looking at real-world outcomes. Golden rice is the perfect example. Millions of dollars have been poured into it as a perfect PR campaign to rid the world of a vitamin A deficiency in children. But in reality, it hasn't delivered, has been tested scandalously on Chinese children before it was approved for human consumption, and all that money could have just been spent on an educational campaign to cook carrots with your rice for vitamin A, since a giant campaign is going to be needed anyway to get people to eat the yellow rice. So we're not going to focus on the techno-fantasy pipe dreams of how GMOs could be saving the world. We're going to look at how they're actually affecting the world today. Number 1, GMOs won't feed the world. We're going to look at the evidence on both sides of the argument as to the yield increase that is promised with GMOs. Is it stacking up? First, let's go to the Union of Concerned Scientists, the same people that warned us about global warming, and look at their report, Failure to Yield. They state that GMOs have not increased yields, and just like any other farming method, they can sometimes be slightly lower yields, sometimes slightly higher yields, but overall, it doesn't really make a difference. And keep this in mind for the next point, quote, public discourse on GE should carefully distinguish between operational yield and intrinsic yield, saying that GMOs have not been proven to have intrinsic yield. Intrinsic yield is basically the genetic modified component actually increasing yield. Operational is just what else the farmers are doing that might increase or decrease yield. That brings me to the crown jewel of the pro-GMO argument, that German meta-analysis that showed that genetically modified crops increase yield. Didn't it claim a 22% increase in yields and 68% increase in profits? Weren't those profits mainly in the developing world? Well, yes, I'm about to pull that card. Correlation is not causation. The increase in yields may have been correlated with the GM seed use, but the cause is most likely just the modernization of farming, because there are some major flaws in this one. First of all, over 50% of the studies were just on Bt cotton. You can call that cherry picking or cotton picking, but I'll let that slide for now. But what I won't let slide is it appears they didn't control for fertilizer use. And as much as I don't support chemical agriculture, here is what fertilizers did for us when we introduced them. It helped us through at least a doubling in productivity. They also didn't compare these yield increases to yield increases that could be expected by upgrading to modern seeds that aren't GMO. They also left out the effects of growing assistance programs from seed companies. All of those things are operational changes that you can make to affect yields. They are not necessarily yields from the genetic modification itself. They also only looked at 3 countries, 60% of the studies were only 1 season long, and foods that actually feed populations like soy was only 14% of the studies. The meta-analysis could more accurately be called calorically irrelevant cotton yields in developing world are associated with GMO use and increased fertilizer use and modernization and modern seed use. A meta-analysis. Now really quickly moving on to other methods of farming that seem to be pretty promising for actually feeding the world with a rising population. There's symbiotic root fungi or mycorrhizal fungi, which can work with 90% of plants. A study that compared 78 field trials found a 37% increase in yields, and another study looking at over 200 greenhouse trials found a 23% increase in yields. These yield increases are superior even to the questionable claims of GM crops. Then there's that 300-page UN report that shows that small-scale farming is a great way to feed the world. And the Rodale Institute's 30-year-long farming systems trial that showed that organic farming outproduces conventional farming in times of drought. And for the granddaddy of feeding the world, since 50% of grain is fed to livestock worldwide, we could just feed it to humans, which is 10 times more efficient. There you go. Reason number 2, health risks outweigh the health benefits. It's official, GMOs don't instantly kill you. People that put together a meta-analysis of animal studies said, quote, there were no indications of any unusual trends in health of animals since 1996 when GMO crops were first harvested. But the fact remains that the majority of these studies were done by the genetic modification companies. Critics say that what these studies ignore is that they were looking at livestock studies of really unhealthy populations of animals, also just studying biomarkers that are important for business like weight. If it didn't kill them in the few years it took them to get to the slaughterhouse, it was okay. If you look at dairy cows, for example, they're often thrown away after 5 to 6 years because they're so unhealthy, when they could potentially be living 15 to 20 years easily. So it'd be pretty difficult to tell if GMOs were actually making them sick when they were already sick. We know from this that GMOs don't make you instantly drop dead. A pro-GMO argument would not be made complete without mentioning that Seralini rat study, in which the study was withdrawn from journals, it was discredited entirely, he had a book deal coming out, things like that. But one bunk study isn't enough to discredit all of the other studies, like this one published in The Lancet that catalyzed France's decision to reject GMOs. It was Arpad Pusztai's study showing abnormality in the intestines of rats after they ate GM potatoes.
They asked me, would you eat it? I said, no, certainly not the GM potatoes we worked on. If I could avoid it, I would certainly avoid it.
Despite his track record of 300 published papers, he instantly lost his job, setting a precedent for what happens if you publish anti-GMO studies. Due to the controversy, it was reviewed by an extra-large board of 6 peer reviewers, which eventually passed it. He stood by his findings even up until one of his last interviews in 2009.
The GM had a slower growth. It had problems with internal development of its organs, and it certainly knocked out the immune system.
Then there's a study by the Austrian government showing strange effects after a few generations of eating a GM diet. Looking at GM rats, the, quote, group had significantly smaller litter sizes. Also, in the third litters, the average litter weights were statistically significantly lower in the GM group at birth, pointing to, quote, the high number of deregulated genes that had been identified as differences between both groups could indicate a complex nutrition-host interaction. Moving on, there was a study showing that goat testicles had differences in a group that ate GM food. And then moving on to the pro-GMO study, even found that when they fed GM food to sows, their white blood cell counts lowered. They didn't contribute this to dangerous, but it goes directly against the idea that there's no difference between GM and non-GM food. If it really isn't a big deal to just change one of 1,000 proteins, then how could it have an effect on the blood cell counts of a pig? We should have a better idea in 3 years when the $25 million Russian GM mouse feeding study is completed. In the end, even if GMOs are perfectly safe for human consumption, we know for a fact that the way they are grown is not. That brings me to how humans are not Roundup ready. This is a huge negative effect because today approximately 90% of soy and 70% of corn and cotton is grown using Roundup. You've probably heard a lot about glyphosate, the active ingredient in Roundup. Our body is actually pretty good at dealing with glyphosate, but Roundup itself is a toxic soup with other chemicals that help glyphosate penetrate cells. When you compare their toxicity on human tissue in the form of placenta, you get this. Glyphosate alone, not that toxic. Roundup is extremely toxic even at low concentrations. It also manipulates your hormones. In fact, Roundup is 125 times more toxic than glyphosate alone, making it one of the most toxic pesticides out there. But soon it will be even more toxic. We will be mixing glyphosate with 2,4-D, one of the main ingredients in Agent Orange, which was used in the Vietnam War. The FDA approved this new herbicide, which will be used on the next generation of 2,4-D resistant GMO crops, despite 60 members of Congress writing a letter to counteract it. The USDA predicts that by the year 2020, we will be spraying 176 million tons per year of 2,4-D. As for health effects, the CDC claims that it deforms sperm, and the WHO classifies it as a possible carcinogen, and that's just the tip of the iceberg. And what about the FDA? Should we trust the FDA with health issues when it comes to genetically modified foods? I'm not trying to get all conspiracy theory here, but I just want to appeal to history really quickly. In 1992, the FDA claimed that GMOs were not substantially different than conventional crops, therefore they were safe. And that's how they entered the market in the first place. But it turns out that the person running the show at the FDA, the official Michael Taylor, was the former attorney for Monsanto. So all this stuff has been crooked from the beginning. Now that doesn't mean we should distrust all studies done on GMOs, but it means that we should be a little bit more critical when looking at sources and whether a multi-billion-dollar company funded it or not. Continuing the history lesson, in 2000, 300 products containing Starlink corn in the food supply were recalled because it was not approved for human consumption. And another important question, why did Starlink corn later withdraw its application for human consumption and just settle with animal consumption? And to emphasize how sketchy GMO foods are in the food supply, Starlink corn was later found in Saudi Arabia in food in 2013, over a decade later. And it's not a one-time thing. In 2006, they had Liberty Link rice, which also snuck its way into the food supply before it was approved for human consumption, resulting in $750 million of compensation to rice farmers from Bayer, the company that made it. Now for reason number 3, profitability. I can't in good conscience link that 68% increase in profit figure from the German meta-analysis to GMO specifically, so we're gonna have to look elsewhere. There are several resources saying that profitability is about the same in the US, like Iowa State's Leopold Center, who did an analysis on corn farmers in the US. One thing is for sure, profitability is set to go down as application of herbicides are going to have to increase as we're getting more herbicide-resistant weeds, and we're also starting to see the beginnings of Bt-resistant cornworm. Bt is the toxin that a lot of plants have been genetically modified to create on their own as a pesticide. But there are other methods of farming that do increase profitability, like organic agriculture. Here's a meta-study that looked at 55 different crop varieties on 5 continents and found that organic increased profitability over conventional by 22 to 35%. Saying, quote, total costs were not significantly different, but labor costs were significantly higher by 7 to 13% with organic farming practices. And that's money that's going to people instead of chemical companies. Now for point number 4, which is environmental hazards. This brings me to the GMO that almost killed the world, or Klebsiella planticula, which is a bacteria that grows in the root systems of virtually all plants. After being genetically modified to produce alcohol, which is toxic to plants, it was found to turn plants to mush in the lab. When students who helped develop this were about to put it into field trials, a professor by the name of Elaine Ingham held up a big red flag. She went before the New Zealand Royal Commission and said that since it produces enough alcohol to kill plants, that if released into the wild, it could potentially destroy all plants in worst case scenario. It most likely would have been outcompeted by other soil bacteria, but is it really worth the risk? As she said, quote, current testing procedures required by US regulatory agencies are completely inadequate in assessing the potential risk involved with genetically engineered organisms. They kind of tried laughing her off, but in the end, the point is they didn't release it. Now moving on to herbicide, a USDA report showed that the herbicide use on GMOs between 2001 and 2010 increased from 1.5 pounds per planted acre to 2 pounds. And non-GMO herbicide levels remained pretty constant. Then there's pesticides and honeybee collapse, which might be the most threatening ecological effect yet. Neonicotinoids, which are believed to be largely responsible for honeybee collapse, are sprayed on 95% of crops, of course the vast majority of which are GMO. So a GM system relies heavily on these pesticides, which are collapsing honeybees, which we all know is detrimental for human survival. Now for reason number 5, food security. GMOs are inherently a technology that favors large corporations over the average person. Patenting seeds is a control issue and it could have detrimental effects. What is the risk to food security when 75 to 80% of our main staple crops are patented by companies? And the whole connection between genetically modified foods and their corporations and the government has led to an overinflated bubble. And finally, a lot of the contracts with genetically modified food make it so that you can't replant extra seed, which can be especially detrimental in developing countries. In conclusion, there's no compelling evidence that GMOs are needed to feed the world, especially when we have other solutions like eating less animal products. The health risk of consuming GMOs is still open for debate, but the negative effects of the pesticides and chemicals used in growing GMOs is certainly not. Next, the profitability is no better than other modern methods of farming, and it is certainly worse than the profitability of organic farming. But the large chemical companies are undoubtedly taking home the profits. Furthermore, the current and potential ecological effects are disastrous, and from a food security perspective, it's a pretty dark path. In a perfect techno-fantasy future, GMOs would be a great choice. But until then, we should at least label the stuff. Feel free to let me know down below if there are any points I missed on either side, and thank you for watching.
I'm forgiven by humanity if we don't do it but use them as our guinea pigs.